We're now going to turn our attention to key error handling operators defined in the Project Reactor Flux class. These operators handle errors or exceptions that occur in a Flux chain, and we'll be taking a look at onErrorContinue, onErrorResume, and onErrorStop in the rest of this video. We'll start with our discussion of the onErrorContinue operator. This operator is designed to recover from errors by dropping the incriminating element from the sequence and continuing with the subsequent element. The parameter that's passed to onErrorContinue is a byconsumer that is fed with errors that match the predicate and the value that triggered the error. The type of the error is actually a subclass of throwable, so it's typically some type of exception. The onErrorContinue operator returns a flux that attempts to continue processing when the errors or exceptions occur. This operator swallows the exception so it doesn't propagate further up the call chain or the call stack. This is a concept known as error hiding, which has pros and cons, as you can imagine. Here's a simple example that we'll take a look at when we get to the case study at the end of this overall lesson. This is an example where we're going to create a flux stream of integer values, which are representing denominators, and then we're going to go ahead and create a big fraction that uses the generated denominators. And one of those denominators is going to be 0, which of course is going to trigger an arithmetic exception error. This particular implementation we're showing here uses the onErrorContinue operator to continue the processing, to basically ignore the element that threw the exception and continue processing other elements that are going to be omitted as part of that flux stream. Keep in mind, however, that onErrorContinue has an interesting and somewhat subtle side effect on the use of the onErrorResume operator, which we're going to talk about here in just a minute. In particular, onErrorResume is ignored if onErrorContinue appears downstream. And we'll talk later about how to get around this. The way to get around this, if you really want onErrorResume to take precedence over onErrorContinue that occurs down the stream later, is to use the onErrorStop operator. And we'll talk about that also by the time we're done with this video. Interestingly enough, RxJava has no direct equivalent to onErrorContinue, which is kind of a shame because it is a very helpful operator in some cases where you want to keep the processing going. Let's now turn our attention to the onErrorResume operator. This operator is used to subscribe to a return fallback publisher when any error occurs. Once again, there's a parameter passed to this. It's a little different from onErrorContinue, which took a byconsumer. In the case of onErrorResume, the parameter is a function, which is a functional interface from Java 8, that chooses the fallback, depending, of course, on the type of the error or the type of the exception. The type of the error is, once again, a subclass of throwable, just like it is with onErrorContinue. onErrorResume will return a flux that falls back to the publisher when an error emission or an error signal occurs. As with onErrorContinue, this operator swallows the exception so it doesn't propagate any further up the call chain or the call stack, which once again is this concept of error hiding that comes with pros and cons if you look at the link at the bottom of the slide. Here's another example to illustrate, or somewhat different example that illustrates how to use onErrorResume. Once again, we're going to be generating a stream of integers as denominators. We're going to be using those denominators to create a big fraction, and one of the values in the stream will be 0, which will trigger the arithmetic exception. And in this particular case, what we're going to do is we're going to convert the error that we just caught to an empty flux. So what happens here is that all the elements of the stream that were emitted before the exception will be processed further down the stream, but everything from where the error occurred and then subsequently will be ignored, because when we return the flux empty as the fallback, then stream processing will no longer continue after that point, although the other elements that were emitted earlier will be processed by the remaining operators in the stream. And we'll talk about onErrorStop just a moment. Beware again that if you have onErrorContinue occurring after onErrorResume in a stream, then onErrorResume will be ignored. It basically, onErrorContinue will take precedence, if you will, over onErrorResume. So be careful. It's a very, very subtle problem. There's a nice link at the bottom of the slide that talks about this in more detail, and it's worth reading it and trying out some of the examples because they're very insightful. We'll talk again in just a minute or two about onErrorStop and how that can be used to overcome this precedence issue with onErrorContinue when it's compared with onErrorResume. There's an RxJava method in observable called onErrorResume next that works pretty much the same as onErrorResume does in Project Reactor. I don't know why they decided to name them different names. I don't know why they're not more consistency in error handling, but this is one of the cases where RxJava and Project Reactor differ a fair amount in terms of their semantics and the syntax. There's also a method that's defined in Java completable future called exceptionally. That's a little bit similar to onErrorResume, where you can catch an exception that's thrown in a completable future chain and then go ahead and override the return value and keep going. Now let's talk about onErrorStop. We've alluded to it several times when we talked about onErrorContinue and onErrorResume, so let's spend a little time explicitly talking about what it does. If an onErrorContinue variant is used downstream, then the semantics of onErrorStop is to revert to the default stop mode where errors are terminal events upstream. And so what this does is it returns a flux that terminates on an error, even if onErrorConsume is used later on down the stream. This can be used for easier scoping on the next failure strategy or to override the inherited strategy in a substream. So here's a simple example of this coming from what we'll look at when we get to our case study at the end of this lesson, where we've got onErrorResume, but then further down in the stream, you don't see it here, but it would occur in the context in which this call is made. There's a call to onErrorContinue. And so what we want to do here is use onErrorStop after onErrorResume to basically say, yeah, we really want to stop. We really want to have onErrorResume handle this, not let it be propagated up to the onErrorContinue, which has, of course, a very different semantic, which could be unexpected in this situation. So if you don't really know the context in which your code's going to be called, and you want to make sure that onErrorResume actually does what you tell it to do with its fallback parameter, then you need to put onErrorStop after the call to onErrorResume. There is no effect of using onErrorStop if onErrorContinue does not occur later on down the stream. So it doesn't harm anything to put it there, but if onErrorContinue does occur, then you'll be protected. Once again, there's no direct equivalent in RxJava. And of course, the reason for that is because there's no equivalent to onErrorContinue. So this ambiguity and this precedence issue doesn't arise in the context of RxJava and its error and exception handling. So that's the end of our discussion of some of the interesting error operators that you have in Project Reactor's Flux class. Little subtle, takes a while to get it right, but can be very powerful and helps to make your programs more resilient.